Welcome to homework.
First, we're going to get the value for R1 for the first orbit. So this is going to be the orbit with the smallest radius. So looking at the equation for any of the radii, we see that we have n squared on the top. We have h squared, which is the square of Planck's constant. In the denominator, we have 4 pi squared. We have the Coulomb constant, capital K. We have the mass of the electron, and we have q squared, or you can also write e squared. But this is the charge, the square of the electron charge. So up here, we can go ahead and write this as the constants that are involved. So we'll write 6.626 times 10 to the minus 34. And the answer we're going to get will be in meters. So I'm not going to worry about putting in the units here. I'm just going to put in the numerical factors. And I'm just going to leave n squared right here. And then we have 4 pi squared. And for the Coulomb constant, you're going to have 9 times 10 to the ninth. For the mass of the electron, you're going to have 9 times 10, or rather 9.11 times 10 to the minus 31 if you're in kilograms. And finally, we have the square of the electron charge, which we don't worry about any sign, but we have 1.6 times 10 to the minus 19. And this is squared. So when you carry this out, this calculation, you get n squared times what we could write as little lowercase k is just the basically lowercase k here is what all of these numerical quantities will come out to. And what we have for that, we get 5.3 times 10 to the minus 11 meters times n squared. And for consistency, let me make one little correction here. I'm just going to write k on the other side of n squared. Other books use a different notation. They'll call this a naught, which is oftentimes the symbol instead of this little k. It just depends on the book you look at. But this is known as the Bohr radius. Now you can also write this in nanometers. And if you do so, that will be 0.053 nanometers. I'll show you the conversion for that. That 1 nanometer is equal to 1 times 10 to the minus 9 meters. And this is very important, a very important unit if you work with optics, you work with atoms, or even molecules. Nanometers is a very important unit. We can show that if we convert 5.3 times 10 to the minus 11 using this conversion factor, that we will get 0.053. So a quick conversion exercise will demonstrate that. So we go ahead, we write meters on the top here, and we multiply 1 nanometer here, divide by 1 times 10 to the minus 9, and this is in meters down here. The meters units will cancel, and we'll have 5.3 times 10 to the minus 11. But now this 10 to the minus 9 in the denominator will move to the numerator. So now we have times 10 to the plus 9. This now equals 5.3 times 10 to the minus 2. And that is the equivalent of dividing by 100. So we now have 5.3 over 100. And this is the same as moving the decimal place to the left twice. So we now have 0.053, and the unit is now nanometers. So indeed, we do get the Bohr radius in nanometers as 0.053. So moving on, we want to get the next 3 radii for the hydrogen atom. So R2 is equal to K times 2 squared, and we can either work in meters or nanometers, so I will simply give you the result in both units. So R2 is, I'll just write the 2 squared first, and we'll put the number that we got, the 5.3 times 10 to the minus 11, I will put that right here. This is in meters. And then I'll give it in nanometers. So this is in meters. This is equal to 4 times 5.3 times 10 to the minus 11 meters. And then when you multiply 4 times 5.3, you end up with 21.2 times 10 to the minus 11, which is equal to 2.12 times 10 to the minus 10 meters. You could just keep it to 2 decimal places if you like. So then we get 2.1 times 10 to the minus 10 meters. And that is equal to 0.21 nanometers. And I'm not going to do the conversion. You could verify it yourself. So you can just go ahead and do that. Now we're going to move on to R3, and we will have 3 squared times 5.3 times 10 to the minus 11 meters. And we get 9 times 5.3 times 10 to the minus 11. This is equal to 47.7 times 10 to the minus 11, which equals 4.77 times 10 to the minus 10. And again, I'm just kind of leaving the units off for the intermediate steps. We can keep this to 2 decimal places, and we get 4.8 times 10 to the minus 10 meters. And when we convert to nanometers, we simply get 0.48 nanometers. And for the last radius, we have R4 is equal to 4 squared times 5.3 times 10 to the minus 11 meters. And I'm going to go ahead and just kind of move down to leave some space here. And we have 16 times 5.3 times 10 to the minus 11 meters equals 84.8 times 10 to the minus 11 meters. And this is equal to 8.48 times 10 to the minus 10, which again, we can round it to 2 decimal places to get 8.5 times 10 to the minus 10 meters. Or we can convert that to nanometers, and we have 0.85 nanometers. And that's it.